Relying on a single AI model for a high-stakes professional decision creates a dangerous point of failure. These systems have invisible flaws in their architecture that eventually give way under the weight of a complex query. Because large language models are engines built for next word prediction, they prioritize sounding human and fluent over factual accuracy. They are designed to be convincing, not necessarily correct. This reliability gap is widening. For simple summarization, hallucination rates plummeted to 0.7%. But on complex professional queries, like legal and medical research, failure rates hover between 15 and 18%. The models sound certain, but still make things up. This is the confidence trap. It happens when a model presents a complete fabrication with the exact same linguistic certainty as a verified truth, leaving the user with no internal signal to tell them what's real. In 2024 alone, unverified AI hallucinations cost businesses an estimated $67.4 billion. Since we cannot engineer these errors out of a single model, relying on an isolated AI for a major decision shifts from using a tool to accepting a massive, unedged liability. If isolated models are inherently risky, how do analysts and strategists actually deploy this technology when the stakes are high? In medicine, complex cases are handled by a consilium, a board of specialists with different training. We can apply that same principle to AI by using different model architectures to peer review one another. This boardroom approach orchestrates 5 frontier models simultaneously. Each model comes from a different provider with distinct training data and architectural biases. We assign them specific roles. Claude handles the nuance and synthesis of the closing analysis, while GPT acts as the structural logician, looking for flaws in the reasoning. Gemini provides massive context synthesis. Grok injects real-time data from social intelligence, and Perplexity handles strict factual grounding through live web citations. By forcing these models into the same thread, their individual, uncorrelated blind spots can cancel each other out. The process stops being about generating text and starts being about verifying that text against 4 other sets of training data. In this environment, the models aren't isolated. They're tied into a shared context fabric, where every model is required to read and critique the responses of the models that came before it. We can track this kill chain as an error is caught. First, GPT makes a logical, strategic claim based on its internal parametric memory, which may be months or even years old. Perplexity immediately cross-references that claim against live web data, flagging it as stale or unsupported by current market facts. Finally, Gemini or Claude synthesizes that contradiction, ensuring the final deliverable highlights the error and provides the corrected context. This works because hallucinations are stochastic. They are random. It is highly unlikely that 5 differently trained models will fabricate the exact same false data to fill the same knowledge gap. This makes disagreement a valuable feature. It transfers the heavy burden of manual fact-checking from the human operator back onto the AI ensemble itself. This isn't theoretical. We can see the mechanism working in real production data from the April 2026 Divergence Index. On financial queries, models disagree over 72% of the time. In the legal domain, that disagreement rate is over 41%. Across over 1,300 real-world turns, 99% of queries surfaced at least one contradiction, correction, or unique insight that a single model would have missed. The confidence trap is visible in the numbers. 51% of Gemini's high-confidence answers were directly contradicted by a pure model in the same turn. We also see a catch ratio of nearly 10 to 1, where specific models like Perplexity catch far more errors in their peers than they introduce themselves. Adding live web access through the ensemble is the single biggest reducer of hallucinations, cutting overall error rates by up to 86%. A single model's output only feels perfect when it isn't being challenged. The data proves that under peer review, those perfect answers are consistently exposed as incomplete. You can also use this boardroom actively through AI red teaming, using the ensemble to try and break an idea before it's executed. Instead of asking for help, you propose a strategy and instruct the models to attack it. They hunt for vulnerabilities across financial, regulatory, and technical vectors. The result is a structured risk register. It quantifies the severity and likelihood of every failure point the AI's discovered and maps out a specific mitigation plan. This forces the models to stop trying to please the user and start looking for failure. It is an automated way to strip away confirmation bias. This does add friction. Running a 5-model adversarial debate costs more in API tokens and takes more time than a standard chat. But paying that cost in software is a simple insurance policy against deploying capital into a strategy that can't survive a 10-minute AI review. The choice comes down to how much error your work can tolerate. You are trading speed and token cost for a defensible, auditable level of accuracy. On this horizontal axis, we have the need for ground truth. On the vertical axis, the stakes of the decision. The bottom left quadrant, low stakes and creative tasks, is where a single model excels. For drafting an email, brainstorming a headline, or writing basic code snippets, a single model is fast, cheap, and perfectly sufficient. But the top right quadrant represents high-stakes work that requires factual precision. When you are finalizing a contract, validating an investment, or conducting technical due diligence, multi-model orchestration becomes a requirement for safety. If an undetected hallucination will cost you money or your professional reputation, you have outgrown the single-model workflow. Building an adversarial system where models are forced to keep each other honest provides a level of reliability that no isolated AI can match.